Thank you, Doctor.
Thank you.
If anything was not understood by the students, another participant, we have another participant in our meeting, Dr. Mustafa Muhammad Abdul Hussein. He was my graduated PhD student. I think it's here now. He can speak Arabic and he can speak Persian, and he can help to translate the Arabic question of the students into the Persian. I can answer to them in the end of my presentation, inshallah.
Perfect. He's with us today?
Yes, I think it's maybe is here. Dr. Muhammad Mustafa Abdul Hussein.
Yeah, I can't see him here, but
Okay.
it will be very nice if you have him today. Just let me explain to the students in Arabic. طلبتنا الأعزاء دكتور علي من جامعة فردوسي من طهران إن شاء الله من مشهد العفو. اليوم راح يعطينا محاضرة عن برنامج DOC اللي هو يختص بدراسة السويل ستابيليتي. ومثل ما تعرفون هي المحاضرة بالإنجليزي، فأي شخص يعني يشوف أكو شغلة ما فاهمها يعني بخاصة اللغة يقدر يرفع ايده اثناء المحاضره حتى نترخص من الدكتور ونساله او انا اترجم لكم، او اذا عندكم اي سؤال يخص المحاضره نفسها يعني علميا نخليه على نهايه المحاضره، تقدر ترفع ايدك وتقدر تسال الدكتور بشكل مباشر. اوكي اخوان؟
تمام دكتور ان شاء الله.
دكتور علي.
دكتور عمار بس ملخص لك اكو طلاب جاي يدزون هواي ما جاي يضيفهم.
الكباسيتي محمد سعدت هسه يعني الكلاس ممتلئ، هسه راح نحاول نفتح لكم شو اسمه زوم وندزل لكم الرابط الشيرنج على الزوم ان شاء الله. هسه ثواني انا راح ارتب الامور ان شاء الله ادزل لكم اياه على الشات. دكتور علي, thank you very much for your patience. Please forward with your session today.
Thank you, Doctor. I called Dr. Mustafa Muhammad Abdul Hussein now on WhatsApp, and he's going to go to this session after the joining us. Please let him the access for the speaking to translate some question of the students.
No problem. Excellent. Thank you very much.
Thank you, Doctor. Bismillah ar-Rahman ar-Rahim. In the name of God, Salamun Alaikum. I hope you and your family are doing well during this coronavirus pandemic. I'm Ali Akhtarpour. As Professor introduced me, I am an assistant professor in the Ferdowsi University of Mashhad in the field of geotechnical engineering. I teach some related lectures and courses in my university, such as soil mechanics, foundation engineering, embankment, dams, unsaturated soil mechanics, and for the Bachelor of Students and also MSc and PhD. I have graduated many Iraqi students from the Ferdowsi University, and I was the supervisor of his or her thesis, and they are graduated and coming back to Iraq, and they are my near friend, very nice friend for me, and I have a good opportunity here to work with the Iraqi students, and I invite all the students to apply for the post-graduation for in the University of Mashhad in the field of geotechnical engineering, inshallah. I was found for a subject that can be useful for bachelor students. The main problem in our universities is the large distances between what you learn in the university and what you need to know. In the future job, because the university can not the lecture you pass in the university is not applicable for the jobs you will need in the future. One of the main subjects in the geotechnical engineering that is very important for civil engineering to know is the slope stability. Because the many collapse and many sudden rupture, sudden collapse of the buildings caused by the unstable excavation during the construction. As you know, the soil behavior is very complex, and also the shortage of knowledge of the engineers, graduated engineers from the university is another main reason for that collapse, for that phenomenon. So I decided to have a presentation with a title of Stability of Earthen Slopes, more soil slopes, I mean, using geostudio software. In the first part of my presentation, we have a review on the previously studied soil mechanics course in the field of soil strengths. As you know, more common criterion for failure of the soils is morculum. The soil has a parameter called phi and c to introduce the shear strength of the soil. I have a brief review on the soil shear strength. After that, we will evaluate and we have a review on the slope stability theory, theory of slices. And in the second part of our presentation, inshallah, we will learn you the use of geostudio software for solving the slope stability problems. After the lecture, you can have questions, and I will answer your questions. If anyone wants to have the software, the cracked software with the full license, please just send me a text, a message into the WhatsApp. I will tell you by contact information, and I will send you the full program with the cracked full license. As you know, it's a very expensive license, very expensive program if you want to buy the program. So let me start. Landslide and destruction of the land is one of the big problems in the engineering. Here you can see a sample of landslide in the New Zealand highway. Many of this happens, many of these disasters every day occurs in the world, in many countries. Natural slopes or hand-made slopes. Shear strength is a term used in soil mechanics to describe the magnitude of the shear stress that a soil can sustain. The shear resistance of soils is a result of friction and interlocking of particles and possibly cementation or bonding at particle contacts. So two parts of shear strength. We have interlocking particles and cementation or bonding between the particles. First one called internal friction, and second one commonly called cohesion. The average normal intergranular contact force per unit area is called the effective stress, as you know. Average normal intergranular contact force between force per unit area is called the effective stress. If water is not allowed to flow in or out of the soil, the stress path is called an undrained stress path. So we have two types of stress paths, undrained and drained stress paths. During undrained shear, if the particles are surrounded by a nearly incompressible fluid, such as water is surrounded by the particle, then the density of the particle cannot change, and without drainage, but the water pressure and effective stress will change. On the other hand, if the fluids are allowed to freely drain out of the pores, then the pores pressure will remain constant, and the test path is called a drain stress path. So two types of the loading, drained stress path and undrained stress path. The soil is free to dilate or contract during shear if the soil is drained. In the undrained stress path, no any change in the volume of the water can occur, but in the drained stress path, the change in the volume can be occur, and the particles can get together, and the soil skeleton getting compact, and the friction will behave in the soil as a main phenomenon. The soil is free to, soil is particularly drained. Somewhere between the perfectly undrained and drained idealized conditions. In reality, in the field, the stress conditions commonly is for the mixed soil, and for the fine soil, especially, is somewhat between the full drain condition and full undrained condition. So we need to choose the shear strength parameters of the soils correctly. In the long term, commonly we use the long term shear strength of the soils called the effective stress parameters. But in the in the short time, immediately after the excavation, in the short time stability analysis, we can use the only cohesion and eliminate the friction angle of the soil just for the saturated fine soils. But for the sands and coarse aggregate soil, we should use the cohesion, effective cohesion and effective friction angle. The shear stress of soil depends on the effective stress. As you know, the drainage condition, so the shear stress depends on the effective stress, the drainage condition, the density of the particles, how packed are the particles. More the packed the particles, more the friction angle. Okay, for the sands, the base friction angle is about 30 degrees. But for higher compaction, after the compacting the soil, we can raise the friction angle of the soils into, for example, 40 degrees or higher. The rate of strain is also affecting the shear strength and also the direction of the strain plan. The more Coulomb criteria usually used to determine the shear strength of the soil. More Coulomb theory is a mathematical model describing the reasons, the response of material such as soils to shear stress as well as normal stress. Most of the classical engineering materials, some follow this rule, follow the Moore-Coulomb equation in their shear failure envelope. Generally, the theory applies to materials for which the compressive strength far exceed the tensile strength. For example, for the concrete, for the soils, and for the rocks, where the compressive strength far exceed the tensile strength. Can you hear me? Do you have my voice?
Yes, Dr. Ali, it's very clear.
In geotechnical engineering, it is used to define shear strengths of soils and rocks and different effective strengths. Moore-Coulomb friction hypothesis is used to determine the combination of shear and normal stress that will cause a fracture of the material. Moore circle is used to determine which principal stress will produce this combination of shear and normal stress and the angle of the plane in which this will occur. According to the principle of normality, the stress introduced at failure will be perpendicular to the line describing the fracture condition. I will explain you on the Moore circles. Here you can see the Moore circle for an element of the soils. We are applying two stress, minor principal stress sigma 3 and the major principal stress sigma 1. The Moore circle is here drawn, and the Moore circle can show the situation of shear stress and normal stress on each plane of the specimen. If you have a plane with a dip of theta on this element, you can rotate from this axial, horizontal axial, in amount of 2 multiplied by theta, 2 theta, in that direction, and the point on the circle defines the sigma and tau, which are the normal stress on that plane and the shear stress on that plane. For the stable element, not a stable soil, not a stable failure surface, just for an element of the soils, the soil is in a stable condition where the Moore circle is below the failure criterion named the Moore-Coulomb failure criterion. So for the stability of the element, the circle must be under this line. If the circle intersects this line, the element is in failure condition, is near failure or in failure condition. That equation, tau F is the shear strength, C is the cohesion of the soils, sigma is the normal stress on the plane, normal stress on the plane. For which plane? For any plane, unlimited number of plane in the soil element, and tangent phi or tangent phi is the friction angle of the soil. If we use this equation in the effective stress field environment, all the parameters have a prime on it. So tau F equal to C prime plus sigma prime tangent phi prime. Okay, it's just a review from soil mechanics, because you should know the basic of the soil mechanics to understand the slope stability of the soil. We have two types of apparatus, apparatus to measure these shear strength parameters. A simple type is the direct shear test. A direct shear test is a laboratory or field test used by geotechnical engineering to measure the shear strength properties of soils or rock materials. The US and UK standards define how the test should be performed are ASTM D3080 and ASHTO T236 respectively. The test is performed on 3 or 4 specimens from a relatively undisturbed soil sample. If you are going to evaluate the slope stability of a natural slope, you should take the specimens in the undisturbed specimens from the field. But if you want to evaluate the slope stability of the man-made embankment, for example, an embankment dam or an embankment constructed for the roadway and highways, or the bridge for the bridge. So in this type of embankment, you should compact the soil with the rulers. So you need to prepare the specimen in a manner that the density of the specimens will be equal to what you compact it with the rulers. So we have 2 types of specimen preparation in the shear strength evaluation test: undisturbed test, and disturbed or remolded specimens. Okay, undisturbed specimens and remolded specimens. Depend of the what you need to evaluate, what you need to calculate the shear strength of the soil, and what is the subject, what is the case you need to evaluate the stability of that. A specimen is placed in a shear box, which has 2 stacked rings to hold the sample. The contact between the 2 rings is approximately the mid-height of the sample. You can see here. A confining stress is applied vertically to the specimens from here, and the upper ring is pulled upper ring, sometimes lower bottom rings, but usually upper one is pulled laterally until the sample fails, or through a specified strain with a specified strain rate. The load applied and the strain induced is recorded at frequency intervals to determine a stress-strain curve for each confining stress. Several specimens are tested at varying confining stress or varying vertical stress to determine the shear stress parameters. The soil cohesion, C, and the angle of internal friction, commonly known as friction angle, phi. The results of tests on each specimen are plotted on a graph, which the peak or residual stress on the y-axis and the confining stress on the x-axis. After doing the test for 3 or 4 specimens, you should plot a linear relation between the y-axis is the shear stress in pitch or in the residual condition. For the dense sand, we have a peak strength. After that, you reach the residual, and you should select the peak strength for the slope stability calculation for the dense sand or the high density clays and stiff clays. But for the loose sand or normally consolidated clays, we have not a pitch. So the curve increase until reach to its maximum without any pitch. You should use the residual strengths to determine the phi and c of the soil. Okay, the y-intercept of the curve of the line which fits the test result is the cohesion. The intersect of the line with the vertical axis is the cohesion, okay? And the slope of the line called the friction angle. So by doing a test on 3 or 4 specimens, you can evaluate the C cohesion and the phi of the soil. The direct shear test can be performed under several conditions. The sample is normally saturated before the test is run, but can be run at the in situ moisture content. You can do the test in 2 conditions, saturated or unsaturated condition. If the slope in the real field maybe experience the saturation, it's very important to do the test in the saturation condition. If you do the test into the unsaturated condition, the cohesion of the soils will be greater for fine soils, will be greater than the saturated soils. But if the soil in the nature saturated because of the, for example, precipitation or seepage water from the surface, or breach the pipeline, sometimes breach the pipeline in urban area can cause the soil get into the saturated condition, and the cohesion of the soil will drop, and stable excavation can be unstable because the reduction in the cohesion of the soils. So it's very important to do the test in the condition when you suggest that the field will experience that condition. The rate of the strain can be varied to create a test of drained and undrained condition. If you do the test in the rapid speed, you just extract, determine the undrained parameter of the soils. But if you perform the test in a slow strain rate, the specimen will be drained, and the specimen is in drained condition. The volume change can be occur, and you extract the drained parameter of the soils or long-term parameter of the soils in that test. There is some disadvantage. The advantage of the direct shear test is it's very simple and is not expensive, and can be do in a relatively short time. But there is some disadvantage of this type of shear strength evaluation test. One of the disadvantages is the failure plan. We force the soil to break, to rupture just on the horizontal plan. You can see here, we force the soil to rupture on this horizontal plan. But in the reality, it's not only horizontal plan. A circle can be formed in the slope, and the failure plan can be rotated during the circle, and any angle, the failure can be occurs not only on the horizontal plan. So it's one of the disadvantage of this type of test. Another disadvantage is the effect of the rigid box. We have a rigid box on top and a rigid box on the bottom, and the soil is confined into this rigid box. The effect of rigidity of the box, it's made of the steel. The box is made of the steel. The rigidity of the box can has an effect on the stress distribution on the failure plan. Okay, stress distribution on the failure plan. It's not we have not a uniform stress distribution of that plan, and can be an ununiform stress distribution on the plan. It can make a mistake or an error in the result of the test. Another better equipment for evaluating the shear strength of the soils is triaxial shear test. As you remember from soil mechanics, the triaxial shear test is a common method to measure the mechanical properties of many deformable solids, especially soil and rock and other granular materials. There are several variations on the test. In a triaxial test, stress is applied to a sample of material being tested in a way which results in stresses along one axis being different from the stress in perpendicular direction. You can see here one axis stress applying different from the perpendicular axis or lateral load. This is typically achieved by placing the sample between two parallel plates, on the top and on the bottom, which apply stress in one, usually vertical direction, and applying fluid pressure in the cell to the specimen to apply stress in the perpendicular directions, okay? By applying the axial stress by a steel rod, and applying the lateral or confining pressure by the fluid into the cell. The specimen placed between the two plates, and it covers with a membrane. The membrane will be a distance between the pore pressure of the soils and the pressure cell. The application of different compressive strengths in the test apparatus cause shear stress to develop in the sample. The load can be increased and deflection monitored. The load increase step by step, and the deflection monitors until failure of the sample. During the test, the surrounding fluid is commonly constant, and the stress on the plate is increased until the material in the cylinder phase and form a sliding regions within itself, known as shear bands. Shear bands is a region in the specimens that the soil will rupture and will fracture on that plan. The geometry of shearing in a triaxial test typically cause the sample to become shorter by bulging out along the sides. After applying a normal axial stress, the soil will deform in a manner that the shape of the sample will bulge, and the bulging means getting a curved shape, yes, will occur near the final failure of the soil. During the test, the pore pressure of fluid in the sample may be measured during pore pressure apparatus. This apparatus has some gauges and some pipes into the logger to monitor the pore pressure in the specimen, to pore pressure of the soil in the specimen, so you can have the monitor the pore pressure in the specimen, and also you can control the confining pressure in the cell. We have for soil samples, the specimen is contained in a cylindrical latex sleeve with a flat circular metal plate or platen closing of the top and bottom ends. The cylinder is placed into a bath of hydraulic fluid to provide pressure along the side of the cylinder, as I told you. The top platen can then be mechanically driven up or down along the axis of the cylinder to squeeze the material. The distance that the upper plate travels is measured as a function of the force required to move it. Okay? Move it as the presence of the surrounding water is carefully controlled. So you can draw the curve of applied strength, applied axial stress versus the epsilon 1 is called the axial strain, axial stress, and axial deformation is also deformation can be plotted. We have three types of triaxial test, as you know. The type drainage test, we call it consolidated drainage or CD, consolidated drainage test. In a consolidated drainage test, the sample is consolidated and sheared in the compression slowly to allow the pore pressure build up by the shearing to dissipate the pore pressure. Okay? The valve of the specimen is open, and after the applying the fluid pressure, the pore pressure can be dissipated during this pipe, and the pore pressure can be zero during the first step of the test. During the first step is applying the fluid pressure. In the second step, when you are applying the axial stress, also the valve is open, and you should apply the load very slowly, and the pore pressure will dissipate through that pipe, and any pore pressure will form during this test. So all the applied stress are effective stress. So you can determine, you can have the drainage parameters of the soils. The size of this soils used to evaluating the shear strength of the saturated fine soils only in long-term stability analysis, and for the coarse grain soils in all conditions, because the coarse grain soils have the large permeability, and when you construct an embankment, and when you excavate an excavation, for example, underground story, to construct underground story of the building, because of the high expensive of the land in the urban area, we need to have the underground stories. It's for example, it can be used as parking for the building, for example. So we need to excavate the land and build, construct the construction, low-level story of the construction. If the soil is coarse grain, sand, and gravel, always, please attention, always you should do the CD test, consolidated drainage test, and always use the drainage parameters of bore column to evaluate the stability of the soil. But if we have a clay, saturated clay, it's some difficult, because in the short term, we should use the Android parameters for slope stability analysis. But in the long term, we should do the long term, and we should perform a CD test to evaluate the effective strength parameter of the soil. Another type of the triaxial test is CU. In CU test, in the first step, we will open the pipes to drain the specimen, but in the next step, we close the drainage pipe of the specimen, and we can monitor the pore pressure into the soil during the shearing off, during the second stage, which is the axial stress applied. Okay, it's a CU test. And another type of the test is very simple test and very low expensive test is UU test, unconsolidated undrained test, unconsolidated undrained test. In the both steps of the test, in the applying the flow pressure and applying the axial load, the valves are closed and the pore pressure in the sample can be formed. This type of the test only just will prepare for us, will give us the undrained parameter of the soils. For example, for the clay soils, in this type, in the rapid test or in the UU test, we have only a cohesion, not any friction angle. The friction angle, we call it phi u or phi u is 0. The phi is 0, and we have only the cohesion. We call it as the undrained cohesion. For the excavation in the clay, unsaturated clay soils, in the short-term stability analysis, we should use the only cohesion, undrained cohesion, and the phi will be 0 for the short time. So it's very important to select the type of the shear strength of the soil. Okay. We have some programs to evaluate and some methods to evaluate the stability analysis of soils. Slope stability analysis is a static, analytical, or empirical method to evaluate the stability of earth and rock field, dams, embankments, excavated slopes, and natural slopes in soil and rock. Slope stability refers to the condition of inclined soil or rock slopes to withstand or undergo movement. The stability condition of slopes is a subject of study and research in soil mechanics, geotechnical engineering, and engineering geology. Analyses are generally aimed at understanding the cause of an occurred slope failure or the factors that can potentially trigger a slope movement resulting in a landslide. The stability of a slope is essentially controlled by the ratio, please attention, the slope stability controlled by the ratio between the available shear strength on a circle and the acting shear strength. Okay, the equilibrium between the available shear strength and active shear stress, which can be expressed in terms of a safety factor. A slope can be globally stable if the factor of safety is larger than unity. The smallest value of the safety factor will be taken as representing the global stability condition of the slope. Similarly, a slope can be locally stable if a safety factor larger than 1 is computed along any potential sliding surface running through a limited portion of the slope, for instance, only within this slope. For each failure surface, if, for example, you can see here, a type of, sorry, let me a moment, please. Dr. Mustafa is here. He wants to join us, but he has not the link. The link. So I should send the link for him. Just a moment, please. I'm really sorry. Okay. Okay, done. Can you hear me?
We are hear you.
Oh, everything is okay? Okay, I'm sorry. Here you can see a slope surface. If please attention, if the soil strength of this soil strength in the all area of this surface is greater, this assumption, the integration of the soil strength in this area is greater than applying shear stress on this failure surface applied because of the, for example, weight of this edge, weight of this polygon, okay? Mr. Mustafa message to me that the permission is necessary for him. Doctor, Professor, please let him to join us. Thank you. Thank you. Let anyone to join us. Thank you. So if the soil strength is more than the shear stress here, the factor of safety will be greater than unity, and it means that the slope is in a stable condition. Okay, but if the applied shear stress here, you can see in the next slide, you can see here, shear stress applied on the surface is equal to final soil strength, then the slope is in failure condition. It near the failure condition, and after that it will fade through that failure line. Let me come back to the slides. There are different factors can affect on the stability of the soil. Before that, we should explain a brief on the limit equilibrium method to evaluate the slope stability or to evaluate the factor of safety. The slope stability analysis is performed to assess the safe design of a human-made or natural slopes, for example, embankments, road cuts, open pit mining, excavation, land pit, and some other things, and the equilibrium conditions. The slope stability is the resistance of inclined surface to failure by sliding or collapsing. The main objectives of the slope stability analysis are finding endangered areas. Please attention, the main objective. Endangered areas, investigation of potential failure mechanism, the area, the danger area, the main objectives of slope stability, potential failure mechanism, determination of the slope sensitivity to different triggering mechanism, designing of optimal slopes with regard to safety, reliability, and economics, designing possible remedial measures, barriers, and stabilization to optimize a slope. For example, if you are designing an embankment dam, you should use a large amount of the soils to construct this dam. If you can choose a steeper, a little steeper slope, you can save a lot of money. You can save a lot of construction time during the construction of a large dam, for example. So it's very important to evaluate the slope stability with a high AQ rate. There are different parameters can affect on the stability of the slope. Soil type, slope geometry, soil permeability, surface and groundwater flow. It's very important. The effect of the water into the soil. I will explain it in our software. Earthquake force, overhead and tensile and shear cracks. Overhead, if you have a constructed building in the vicinity of the excavation, okay, in the vicinity or in the neighbor of the excavation, the load of the constructed building will be applied on the surface, on the top of the excavation area, and the reduction and can cause the reduction in the safety of this factor of safety. Also, how to distribute pore water pressure. We will explain it in the software, the distribution of the pore water pressure, the location of the phreatic line also is very important for the slope stability. Or the existence of faults, maybe it's very difficult to evaluate the effect of faulting on the on slope stability. One of the main, the very new and modern object in geotechnical engineering is to evaluate the effect of faults on the buildings. If a building is constructed exactly on a active fault during an earthquake, the active fault can be ruptured and permanent displacement applied to the surface buildings and surface structures can cause the collapse of the structure. It's very important things, and it's a very modern subject that some geotechnical researchers work on it. Also, we have some students here that they are doing on that subject. To evaluate, we have some failure mode. The failure mode in the limit equilibrium analysis. Just let me have a brief explanation of limit equilibrium analysis. Most slope stability analysis computer programs are based on the limit equilibrium concept for 2 or 3-dimensional model. A stability analysis of 2-dimensional slope geometry using simple analytical approach can provide important insights into the initial design and risk assessment of slopes. Limit equilibrium methods investigate the equilibrium of a soil mass tending to slide down under the influence of gravity. Translational movement or rotational movement is considered on an assuming unknown potential slip surface below the soil or rock mass. For example, in this picture, you can see the potential failure surface into the soils. All methods, we have different methods to evaluating the factor of safety. All methods are based on comparison, based on the comparison of force, moments, or stress resisting movement of the mass with those that can be caused unstable motion. The output of the analysis is the factor of safety. Please attention, the output is the factor of safety for each assumed slip surface. How many slip surface? There are many, a lot of slip surface. Unlimited slip surface is possible, but the factor of safety is the minimum factor of safety for the circle or for the slip surface. That's the calculated factor of safety on it is the less factor of safety, and dominate mechanism of failure is that failure surface. So we don't know where is true tall circle, low deep, a shallow surface, a shallow circle, or a deep circle, or a circle reach to the top. All of this surface may be possible, depends of the geometry, depends of the type of the soil, depends of the location of the water, phreatic surface, and some other thing depend on the layers of the soils. Maybe a weak layer of the soils exists here in the foundation of the embankment, and in this condition, the failure can be passed through the weak layer, and deep failure can be occurred in the in our slope. It's very important because sometimes engineers have a wrong way in this to stabilize this, because they construct, for example, consider a vertical cut. They construct only a structure, for example, a pile here, but the failure will pass below this structure. For example, if you construct a wall, a retaining wall, or a gabion, or some structure like this here, without any penetration into the lower part of the soil, the circle can be occurred, and the fail will be happens in that soil, and the retaining wall have no role to stabilize this type of failure. So in this type of failure, you should construct a construction that can penetrate into the soil, enough penetration to the enough depth to prevent the circle under this penetration part of the structure. Okay. So as I told you, the output of the analysis is a factor of safety defined as the ratio of the shear strength, or alternatively an equivalent measure of shear resistance or capacity to the shear stress, or other equivalent measure required for equilibrium. If the value of factor of safety is less than unity, the slope is unstable. Limit equilibrium methods assume that the shear strength of the material along the potential failure surface are governed by linear, commonly, usually more Coulomb failure criteria. The most commonly used variation is Terzaghi and Moore-Coulomb theory of shear strength, which explains Moore-Coulomb theory relations. And as I previously explained for you, the C cohesion and the phi friction angle of the soils. There are different types for analyze the limit equilibrium analysis. More common and usually we use the slice type method. In the limit equilibrium analysis, because we don't know the location of the failure surface in the beginning of the analysis, it's important to choose an area, which cover all the possible failure surface. All the possible failure surface, you can decide on which failure surface has a lower factor of safety. Yes, so you need to evaluate this type of failure, also this type, in this one and another one. Factor of safety, as I told you, defined as a shear strength of the source on the applied shear stress, or we can call it and the mobilized average shear strength of the soil. Mobilized shear strength is equal to applied shear stress. Attention, applied shear stress is equal to mobilized shear strength in the soil mass. You can see here again the equation of Moore-Coulomb. The ordinary method of a slice is more common for evaluating the factor of safety. For the slice method, we must first choose a shape for the sliding surface. It's very common, it's very usually we choose the circle type failure, but not in all conditions. In some conditions, maybe it differs from the circle. But in the common slopes, the circular type is appropriate for evaluating the factor of safety. After that, we should divide the circle into the slice. Attention here, into the slice. Each slice has a free diagram, body force, free diagram. You can see a weight, also the reaction in the base of the slice. Here you can see this slice. Base reaction of the slice can be divided into two components, TR and NR, normal to the surface and tangential to the surface, and also two sets of the inter-slice force. Two sets of inter-slice. Inter-slice force is the force applied from the next slide and the previous slide, before the previous slide, on the or slide. It's name it here with Pn, Tn, Pn plus 1, Tn plus 1. Because in a static, if you can remember from the static course, in the beginning of your study in the bachelor degree, static, you just have 3 equations for equilibrium, okay? But now we have more than 3 undetermined force. We have here 4, which is not known, which is unknown force. There are unknown force. So the methods we can't use only static equations to evaluate the amount of this force. Okay? Some different researchers.
Dr. Ali, can you hear us? اخواني يمكن دكتور علي طلع من الميت هسه شوي ان شاء الله ويرجع بالدقائق. هسه راح نحاول نتصل به. خليكم ويانا يعني لا تطلعون.
تاخذ قطع الكهرباء عندهم.
دكتور والله بعد ما ادري. بس نحاول نتصل
بالكهرباء. طب
الظاهر فصل النت عندي حتى اتواصل.
شكرا دكتور، شكرا.
زين ما شاء الله طلابنا خوش مشاركه، بارك الله بيكم. هاي الشغلات تستفادون منها رغم انها محاضره مع صف ثالث، بس يعني ايضا تستفادون منها ان شاء الله.
دكتور مصطفى محمد.
دكتور رئيس قسم المدني جامعه المعقل، اعتقد هذا مو دكتور مصطفى اللي هو خريج ايران دكتوراه مالته.
اعتقد
عفوا دكتور صالح ودكتور عمار، بس الطلاب خلي يسجلون بالحضور هذا الاستمارة مالت الحضور بالنسبة للطلاب بدون زحمة.
تمام دكتور.
هم عادة جيم ودال وهاء، فكل واحد يكتب شعوبته أيضا. طلاب لا تنسون لأنه صرتوا أكثر من شعبة، فهذا هو اللينك مال الحضور.
دكتور قصدك كل الطلاب موجودين هنا؟
اي طلاب موجودين هنا، نعم.
هذا دكتور رسالته الرابط.
هذا الحضور طلاب، هذا الحضور هو الحضور اي بالنسبه لشعبه جيم موجود عندهم بالكلاس، وهذا ايضا اللينك، ايضا تستخدم هذا اللينك مباشره اسهل لك.
لا دكتور قصدك هذا الرابع بس غير؟
نعم
الرابط
هذا الرابط مال الحضور طلاب.
دكتور قصدك هذا بس الرابع غير الحضور؟
اي بس الحضور، حضور طلاب الرابع
كلها دكتور حسين، كلها المرحله الثالثه والرابعه. شكو واحد داخل للميت
حتى بالثالث عندنا، حتى الثالث
نعم
عندنا
نعم
أوكي.
نعم مرحله
بس
ثالثه
العفو دكتور
عندنا.
ما جاي يشتغل.
شباب اذا
دكتور رابط
المطلوب
ما جاي يشتغل.
ليش؟
دكتور هذا رابط
ما
كلاس روم
شالوا
مال فورمال.
كلاس ما موجودين احنا بيه دكتور.
هسه
دكتور هذا
شوف
رابط كلاس روم مو فورمال. عفوا
هسه راح اشوف لكم شباب، اعطوني مجال شويه.
خلي ممثل الشعبه يسجل اسماء الحضور مال كل شعبته، كل واحد يسجل ممثل شعبه عشان نختصر الوقت.
او دكتور الاسهل سجلوا بالشات، سجلوا هنا بالشات وانا لم هنا انا اجمعهن.
اي اوكي دكتور، افضل حل هو هذا، نسجل بالشات و
الو الو.
نعم دكتور وياك. نعم
الو دكتور، وعليكم السلام، شلونك؟ انت داخل بالمحاضره؟
دكتور صالح، بس المايك مالتك مفتوح ستة بلا زحمة عليك.
Can you hear me, Professor?
Yes, Dr. Ali, you can continue.
Oh, I'm sorry. I had a problem. I don't know what was the reason.
No problem.
I
We can hear you.
I should again share my screen.
Okay, no problem, you can continue.
Can you see?
Yes, Mr. Yes, Doctor.
So, I'm sorry. We define the factor of safety as the ratio of shear strength over the average shear stress developed along the potential failure surface. Okay, as I explained you, the free diagram of a slice can be seen here, and I explained that the P and T are unknown for us, and we need to have a method to determine this inter-slice force. This called inter-slice force. The simple method, the more simple and inaccurate method was the Frobenius method. In the Frobenius method, we discard, we eliminate this force, and we propose that just a weight is applied, and for the equilibrium condition, we can have an equation like this. Factor of safety is the summation of the shear strength in the base of the slice. Okay, here you can see the part of the cohesion and the part of friction angle over the shear stress applies, just it. Okay, shear stress. If you divide the TR with the area surface, base slice area surface, you can have the shear stress on the base of an slice. The summation of the shear, applied shear, can be the total shear. It's the total shear applied on this slice. But this method is not usually used because of the low accuracy of flanges. Another assumption to evaluate this unknown force was suggested by Bishop's simplified method of slice. Because of the limited time, because of the short time, I can't explain the theoretical basis of this equation, but the equation is some different from the Flanneau's equation. You can see here the effect of cohesion of the base slice, effect of friction, but here you can reduce, you can affect the influence of the pore water pressure. Here UN is the pore water pressure at the base of the slice, okay, multiplied by this term. This term is a term which contains also the factor of safety. So you have an equation, the factor of safety is here, and also the factor of safety is contained in M alpha. So the software needs to have a trial and error procedure, okay? It's very difficult to hand calculating because it's divided into the many slice. The failure plan must be divided into the many slice. For any of the slice, you should calculate the summation and do the try and error procedure to finally calculate the factor of safety. So you just have the factor of safety fit for that proposed sliding surface. But I didn't know where is the exact location of the sliding surface. So as I explained, we need to have a large number of sliding surface and calculate this procedure. After that, the minimum factor of safety is the predominant factor of safety, and the related shear failure plan is the dominated mechanism for the sliding. So it's very difficult to calculate it, but hence we are going to introduce you a software called geostudio for solving the problems. Here you can see a failure, a natural failure of an slope. Okay. So let me pass because the time is limited. So we are going to do a simple example for working with geostudio. This is the environment of the first page of the geostudio software. As I told you, we are going to work with the release of 2018, and I have a version of this software, and I can send all the attendees, all the participants by Telegram the full license of this geostudio. Geostudio contains of the about 7 modules: slope W, seek W, sigma W, quick W, temp W. These are very specialist and very modern and complex software, but in the for the attendees that we are in the bachelor degree, it's enough to introduce the slope W for evaluating the factor of safety. Slope W is used for evaluating the factor of safety. So you can click on the slope W here. Okay. After that, you can use the metric units, and a page like this will be appear. Okay. After the selecting a slope W and choosing the units, you can see here like this. Okay. In this window, here you can see it slope W analysis. Here there is a tab. If you click on the tab, you can see different methods. Which methods? As I explained before. For example, B-sharp, modify B-sharp. Here you can see B-sharp method or other type of method, ordinary jumbo or other type. One of the best methods is Morgenstern price. Okay, it's an accurate method. So you can choose Morgenstern price here, and you can use a name here for your analysis. Okay, Morgenstern price, and analysis type Morgenstern price. There is another tab here. Okay, PW condition from. PW means pore water pressure condition from the software asks you from the PWP, pore water pressure. You have a different choice here. For example, parent analysis, which can see here, parent analysis. If you use another geostudio program, for example, CW, to perform a seepage analysis, like a seepage analysis in an embankment dam, here you can see it, then you can use parent analysis type, and after that, you introduce that file, and the program will extract the pore water pressure from the calculated seepage analysis into the slope W. It's some complex for you. So you need to work with a more simple PWP type condition form. Another type is RU. RU is defined as the pore pressure over the gamma multiplied by H. Gamma H is the surcharge, and RU is a ratio, defines the ratio multiplied by gamma H for every point, and the program will calculate the pore water pressure. Okay, another type is B-Scanton. It's really complex, it's not suitable for you, and more suitable type for introducing PW condition for you is the piezometric line. Piezometric line is the case where we have a piezometric line. So when you evaluate a slope stability, for example, for this type of the dam, you know that the phreatic line is like this in the body of the dam. So you can draw the phreatic line, and the program will calculate the pore pressure from the phreatic line, as I explain later. Okay, a slip surface type. After you choose the PWP condition. You choose the PWP condition. After that, you must choose the sleep surface. Another tab. After the setting tab, you can see a sleep surface. You click on the sleep surface, and you see two types: left to right and right to left. Okay, if the sliding surface is beginning from the left and continue to right, you must choose. You have to choose the left right. But if the geometry is drawn in the hand right, okay, in the right hand, the slopes will begin from the right into the left. So you must choose the right to left. Okay, I just explained the more common expressions here. Some of them is not suitable for you. Okay, just the common and usually used parameters here. Also, you can introduce the region, the limitation, and the region of the sleep surface by two types. Two types you need to know. Another is not important for you. One type is entry and exit. Entry and exit we use when we select. I will show you in some examples. When you select a line, a limitation for starting the circle and the limitation for the ending the circle surface. So the program will start from each point in the upper part into each part of the lower part of the slope. Another type is a good second type, maybe is better, sometimes is better, is grid and radius. When you choose a grid point, an area with a grid, for selecting the center of the circle, okay, and the area for the tangential lines, and the program will draw a circle from each grid in tangential to the lines. You define the limitation, you define the area for the tangential lines. So just two types of defining the sleep surface is enough for you. Okay, here you can see a left to right. It's an embankment dams. Here for upstream, for example, for downstream, and for upstream of the dam, you can see here the right to left type direction of movement. Okay, here you can see the entry and exit. Here the entry region, and here you can see the exit, and you can choose the number of divides here, and the program will draw the circle from each point of the entry to each point of the exit. Okay, here. This is a circle, just one of the circles. We have in many number of circles depending on the whole whole number of division, whole number of points you will choose for that entry and that exit from each point to each point. Okay, maybe more than hundreds of circles can be calculated by program just in a short time because of the high performance of computers, today computers. Grid and radius is like this. Here you can the grid, the center, you define the center of circles, perpendicular or tangential to these tangential lines. The circles here can be formed, can be drawn from each point tangential to the one of that lines. So we have a large number of circles here from each grid point to the each of the lines in the defined regions here. Okay, so you need to define the slip surface area. It's very important. It's very important. You should choose the area that covers all possible failure surface. Okay. In the second part, we explain the units. Units can be view. Please attention. View units, and here you can choose the units. For example, unit for the weight, for the force, for the time. Maybe usually in Iran we use metric units. Maybe in Iraq is similar. Metric units is more common in our calculations. The kilonewton for the force, and the meters for the distance, the kilogram for the mass, and the second for the time. Okay. In the second slide, you can see there are the model geometry. There are the model geometry. Here you can see a simple draw, a simple geometry. First, in the first part, we have to select the points, and we can here see it, and select the points by two methods. Select on the page, okay, or input the coordination here, okay? Input the coordination here, or select on the page. I define 5 points. After that, we must select the regions, okay? Please see again. See again. Here you can define the points by click on the page, or define the points here by input the coordinates, okay? After that, you must select from the define menu, okay? Define menu, draw regions.
Dr. Ali,
yes.
Excuse me. I think you have a problem in your presentation because there is no program page here. Just the presentation, just the notes.
Just the notes?
Yes, please. I think you have to share your entire screen, so to be able to share the program and the presentation PPT at the same time.
I have prepared a short video from the geostudio. Okay. So
now we are seeing just the presentation.
I am showing the short video on the.
Now we are seeing just the presentation, doctor. Just the presentation. There is no program here, because when you are speaking about the program, I think you are presenting the program page. That's right.
That's right. Can you see the environment on the software?
I see it. I see it now.
Huh? Okay.
I see it now. Okay.
Yes. It's a short video prepared before. Okay.
Yes. Because when you were speaking. Okay. Thank you.
Okay. I will continue. Thank you. After that, you must choose the define here and draw regions, and connect the points here. See, please connect the points, and after the final connection, a hatch can be displayed in the polygon. A polygon will be formed here. A polygon will be formed, and a hatch can be seen to its polygon. And here you can see the number of points. Point number 1. From 1 to 2 to 3 to 4 to 5 to 6, okay? And a closed polygon can be formed here. After that, we must introduce the material properties. For example, we have a soil with a gamma equal to 18, cohesion equal to 10, phi equal to 30, and for defining the water pressure, we use the RU method. RU method means the pore pressure ratio method equal to 0.27. Okay, here you can see the defined material menu. Here you click on the add, because I can't click here because it's a video, but you can see on the video in the next slide. Add, and you select a name for the material, click on the tab here. You can see here some different shear strength type model for the soil. More common type is more coulomb. Okay, so you can use the more coulomb. Another type is not appropriate for you, so you use the more coulomb type criteria, failure criteria. Here you should define the failure criteria for that material. If you have many material, for example 5 material, okay, I should press add and define 5 materials here. Each material must be a region, a different region in the geometry input menu. In the next, you can see here a larger picture, a clear picture. Here you can see a video. Please attention. Define materials, add new material, click on the new material, just a name, for example, soil 1, material model, more coulomb. Then you can see here unit weight, 18, cohesion, 10, and phi or phi equal to 30. This type is suction. Suction is not used, and some other advanced tab, it's not appropriate for you. After that, you draw materials. Here you can see the materials. Choose the assign and click on the region. Okay. So here you can repeat it for better understanding. Okay. You can see here draw materials from this icon. After that, select the soil 1. After that, assign and click on that region. Click on this region. Assign soil 1. Click on this region. Okay. The soil 1, considered for region number 1. This is a region, we have one region only in this simple model. Okay, in this simple model, we just have one region number 1. Maybe you can have a different region with different soil type and soil parameters. Okay, in the next slide, you can define the pore pressure ratio here. Okay. Here, define pore water pressure tab. After that, choose soil 1, and RU coefficient is defined here, as I told you, is the coefficient of pore water pressure to the gamma multiplied by H in the RU method. RU method, please attention. RU method just only defines for the fine soils where a consolidation phenomena can be occurred, when the undrained behavior can be occurred, and when a development in the pore pressure into the soil can be occur. Just for saturated fine soils such as clays and silts, it can be used in the embankment dams. Just for the clay core, we use the RAU method to define the pore pressure conditions. Okay, please see again. Define pore water pressure. Select the soil 1, input the RU coefficient, and then close. Next one, draw a slip surface. As you introduced you before, in this model, we use the slip surface, grid and radius type. And after that, you can grid the number of increments. For example, 20, and in the y direction, 10. Divide into the 20 to 10 center for circles. After that, drawing the tangential lines, okay? And the radius increment, the increments 10 divided into the 10 lines. Again, see please. Again, see. Draw a slip surface, grid, define the grid regions. Here, like this. Number of increments, 20, for example, to 10. You should use a large number, for example, 10, 20. This type. After that, a slip surface radius. Okay, a slip surface radius. Here you should define this area and the number of radius increments 10. The program will draw this circle from each of the grid points into each of the tangential lines. In the next analysis. So the definition is finished for a simple geometry. Now it's in the next step, we should from here click on the start. Okay, start here, start. You can see here, start. The program in a very short time calculate the large number of factor of safety for the hundreds of circulars. Okay, in the preference you can control the font number and your vision. If for example, here you can see a slip surface, and the minimum factor of safety. Here, please see here. Here is all slip surface. Auto select critical. See here, you can see auto select critical, all slip surface, okay? And you can see all the slip surface. By clicking on any slip surface, you can see the factor of safety and the failure surface for that. And in the top of the list, you can
اخوان الظاهر دكتور علي هم قاعد يواجه مشكله بالنت، فنبقى ان شاء الله ما يجي هسه ثواني ويرجع.
السلام عليكم دكتور احمد. العفو، من ساعه كان عندي مشكله بالصوت فما قدرت اجاوبك انت ودكتور صالح. حياك الله دكتور صالح. ما اعرف
سلام دكتور
تسمعوني؟
مصطفى، نصيحتك.
الله يحفظك. وبايران هسه حاليا اكو مشكله، الله يحفظك دكتور احمد. بايران حاليا اكو مشكله مال كهرباء، فدائما تنقطع وتروح وترجع، فاكيد هسه
نعم.
شويه ويرجع.
هو قال لنا اول ما دخلنا السيشن قال
إيه.
عرفنا بحضرتك، وقال دكتور
الله.
مصطفى راح يساعدني بالاجابه
الله
على
يحفظك.
الاسئله.
أنا صراحة بين ما يرجع دكتور علي أنه أتمنى أنه المحاضرات المستقبلية، طبعا هذا طلب وليس توجيه، آسف، أنه
نعم.
الميت يعني الكباسيتي مالته ما تتحمل. يعني أنا تقريبا 22 دقيقة أنا قاعد بس أريد أنه أتاني واحد يطلع حتى أقدر أدخل يقول لي this meet is full.
نعم صحيح.
يعني
احنا
فظليت
دكتور
حتى هو تواصل وياي، ها ليش ما اجيت، حتى انا عندي محاضره واجيتها على مود المحاضره مال الدكتور مالتكم. فيعني انه يا ريت انه بالمستقبل، طلب وليس امر، انه فد لينك يعني تخلون، يعني تعرفون انه جامعه البصره ما شاء الله غنيه بالاساتذه والطلاب كعدد وعلميه، فاكيد راح الكل يحضرون مو بس من جامعه البصره، بس انا اشوف اكو طلاب حتى من خارج جامعه البصره.
اي نعم دكتور، احنا خلينا لينك مال زوم ودخلوا عليه تقريبا 40 نفر، يعني
ما
غير
عندي
اللي
انا
موجود.
لينك الزوم، انا ما عندي لينك الزوم، عندي بس
اي
الفايل اللي شاركته جامعه فردوسي.
اي صحيح.
يعني ان
اي
شاء الله بالمستقبل طلعوها. رجع
نخليهم
الدكتور،
اثنين يسوي. اي ان شاء الله.
رجع الدكتور. هاي دكتور، يا ويلكم again. There is no voice, there is no voice. Dr. Ali, there is no voice. Please turn on your mic.
Can you hear me now?
Yes, yes.
I will again share the screen. I'm really sorry. There is a problem in the internet connection, I think.
There is no problem, Doctor. Go ahead.
So in results, can you see?
No, there is no presentation now. There is no presenting now. Please share your screen.
Okay. Is it true?
No. Anyone
No?
can see the presentation? Anyone can see the presentation?
No.
Because
No.
Not yet.
no, right, Doctor.
No?
No, there is no
I will
presentation
share
here.
it again.
You have to refresh your page and click on share again.
Okay.
دكتور عمار، هاي مشكلة الميت نفر بس الكاباسيتي مالته. الزوم اعتقد اكثر، اعتقد 250، وهي هاي كانت المشكلة يعني.
العفو استاذ حسين اذا تسمح لي على المقاطعه، انه الزوم ديبيندز اون، يعني اذا انت مشتري انيوال بيمنت عندك او انيوال يعني اشتراك سنوي، لا يوصل
نعم.
حتى ال 400 500. اذا لا مال ستودنت فيرجن 40، اذا تشتري ابو ال $10 يصير 60 او 120 حسب البيمنت اللي تدفعه. الزوم
هذا الزوم دكتور، الزوم
نعم.
هذا مو
نعم دكتور، الزوم.
اذا نخلي على الميت احسن فري.
اوكي
خلي
اوكي
تو.
اوكي.
لا شوف ان شاء الله
لا
على المحاضرات
بالمناسبة دكتور
نعم.
ممكن انه الجامعة تطلب من الوزارة تجهزهم ب 100 ابو 500 او بال 400
ان شاء الله، ان شاء الله على الجايات. شكرا جزيلا.
ان شاء الله.
شكرا جزيلا.
حياكم.
دكتور مصطفى، هاي الامور الشغله التقنيه سهل ان شاء الله حالينها، بس احنا هذا لين اول محاضره هي تيست.
لا ماكو مشكله، لا بالعكس احنا الغرض من عندها انه نستفاد من المعلومات.
السلام عليكم. السلام عليكم
السلام.
عزيزي الدكتور مصطفى.
حياكم الله دكتور. على ما يبدو انه دكتور علي انه عنده مشكله هم نت وهم كهرباء، بس حتى
احنا حقيقه في هذا البرنامج برنامج الاستاذ الزائر هو ضمن انا مدير مركز التكنولوجيا المعلومات والاتصالات بجامعه البصره.
حياكم الله
برنامج
دكتور.
الاستاذ الزائر الله يحفظه الله يسلمك. برنامج الاستاذ الزائر هو حقيقه اتفاقيه تعاون بين جامعه البصره وجامعه فردوسي مشهد، فالمعنيين به هم طلبه جامعه البصره، يعني مو الطلبه اللي من خارج الجامعه. واحنا الجوجل ميت بالبدايه استخدمنا زوم، عندنا زوم 500، لكن لانه الطلبه معتادين على الجوجل ميت باعتبار انه كل محاضراتهم على الجوجل ميت، ففضلنا انه يستخدمون الجوجل ميت. مع العلم طبعا جماعه فردوسي مشهد ما حابين هذا الشيء، لكن
لا ما يشتغل الزوم هناك الا
اعرف عندهم بلوك على الزوم، لازم يستخدمون في بي ان، يلا يستخدمونه
بلي ويتقطع وهذه.
حتى الجوجل ميت هو هسه اذا جوجل ميت اوكي مو بلوك عندهم، بس هم مو فاميليار وياه، يعني هم يستخدمون
هم عندهم ادوب كونكت،
ادوب يستخدمونه، اكو بلاتفورم ثاني يستخدمونه على الجامعه مالتهم. حقيقه ال100 طالب كانت سفيشنت، لكن فقط بالهندسه تكون مو سفيشنت، فدائما ننسق انا والسيد المعاون العلمي دكتور حيدر انه نخلي زوم ستاند باي، نسوي شير له فيكون اوكي. يعني هسه حتى الزوم اللي فتحها دكتور عمار مشكورا يعني ما دخلوا له اكثر من 40 طالب، يعني فما تستوجب ال 500 وال1000 ولا هن موجودات هاي اللينكات.
تعريجا على كلام حضرتك مو يعني هسه راح ادز لك ملف PDF شاركته جامعه فردوسي بجروباتها، فيعني انه احنا ما نقدر نسوي كنترول على انه خارج الهندسه انه ما يدخل او ما اعرف، اكيد راح يدخلوا لك فد عدد لا باس به، انه يعني ممكن انه يسوي مشكله ويا العدد اللي عندنا. فانا هذا كانت الملاحظه اللي عندي، يعني مو انه
لا هذاك اذا هم يشيرون جامعه فردوسي، مش انا ما اعتقد جامعه فردوسي تشير، يجوز يعني ان اوفيشيالي يشيرون، مو هم كجامعه، لانه ريبريزنتيف مال فردوسي مشهد كونتاكته وياي حصرا، يعني ما يسوي كونتاكت ولا يدز البوسترات لاي واحد ثاني، لكن ممكن بعلاقات البروفيسورز اللي موجوده هناك مع طلبتهم اللي دارسين انا اوفيشيالي ينشرون يعني. لكن اوفيشيالي هي ميموري اوف، يعني هي مذكره تفاهم موقعه، والتارجت مالتها هي الاندر جراجويت ستودنتس يعني
بالضبط.
يعني حتى الكوليجز اللي يدخلون الفاكولتي ممبرز هي لاثراء النقاش والحوار مو اكثر يعني، لكن هو التارجت بالمحاضرات هو الاندر جراجويت ستودنتس.
بلي غرض منها هي مشاركه المعلومات لا اكثر ولا اقل، من الطلبه يستفادون.
لا طبعا شيء اكيد.
وطبعا هذا موضوع شيق، يعني هسه ما دام نستغلها فرصه انه الطلبه، انه الدكتور علي ما موجود، دكتور علي اختربور، انه اني من كنت الطلبه الوحيدين اللي عنده او القلائل اللي اشتغلت هذا البرنامج من الاول للاخير، فاي طالب عنده سؤال استفسار اني حاضر فيما يخص هذا البرنامج لطلبه الBSc، والمعلومه تقدم فري.
هو
برنامج جيوستوديو، وحتى اذا
حضرتك باي جامعه عفوا دكتور مصطفى؟
أنا رئيس قسم الهندسه المدنيه في جامعه المعقل بالبصره.
اهلا وسهلا، اهلا ومرحبا.
الله يحفظك. هذا برنامج
دكتور هي هذه في موازين الاعمال، يعني هي زكاه العلم نشره بالحقيقه. احنا دائما السوفتويرات الجديده
اغلب
ننزل بيها فيديوهات، يعني
اغلب الاساتذه هسه انزل صوره التليجرام مالتي يعرفوني، يعني عنصر فعال في لحظه. هسه هذا دكتور علي دا يتصل بي، بس خليني اشوف ايش يريد من رخصتكم.
براحتك.
سلام ابو دكتور. سلام. شوف دكتور احمد هسه الدكتور دا يقول لي ما اقدر ادخل، يعني العدد اكثر من ال100، فما ينطر يقول له فول. بلى دكتور.
لا هو ما جاي يحاول يدخل، انا اسمح له مجال، انا عندي مجال.
لا فول يقول لي. بلى آقای دکتر دارم صداتون دارم.
پیشنهاد بدید چون هنوز خیلی مونده بخشش. خب پیشنهاد بدیم مابقیشو توی یک ساعت دیگه میام ارائه میدم. پرداختی جدایی هم نمیخواد، هزینه پیمنتی نمیخواد. خب میام توی یک ساعت دیگه ارائه میدم مابقیشو باز.
خب آقای دکتر شما You are welcome again, Dr. Ali.
Can you hear me?
Yes.
Sorry, I think the problem is from internet connection. I think.
Okay, doctor, don't worry. Go ahead. We are in the Middle East. Yes, you are presenting now, doctor. Go ahead.
Could you see?
Yes, it's clear. But don't forget, you have to present all your entire screen.
Yes.
Okay.
Yes.
We see it. Thank you.
Yes. Here you can result, as I explained before, for each circles and also for all circles simultaneously. Okay, all circles. And the red circles are the critical. The most critical is shown previously. Font size, you can change the font size, okay? Font size here and see the factor of safety between two numbers for each color. Each color related to some factor of safety, okay? Next, in the next slide, we can just explain a brief on a slice calculation, okay? You can see here from this icon, the slice, okay? Or here, choose a slice, and you can choose any of these slices and see the free body diagram, okay? By choosing any slice, you can see free body diagram, particle slice force, also the weight, and also the reaction force, as I explained in the basic of the methods. So here you can see all the slice force. In the next, introducing the pore water pressure by piezometric line is more usually common for you. As I explained before, in the first step, in the first window, you have to choose piezometric line instead of RU. Okay. After choosing the piezometric line and follow the modeling and follow the introduction, the material properties, and like the previous example, former example, you reach to the stage that you should define the pore water. Again, we define the pore water and piezometric line. You can here draw the theoretic line into the soil. Okay? Again, please, see again, seeing again. Here, draw pore water pressure, select the type, apply piezometric line, draw the piezometric line here. Okay, done. And the program will apply the pore pressure for each point below the water theoretic line. Attention, please. For the upper part of theoretic line, the pore pressure can be considered as 0 or negative. It's based on the unsaturated soil theory. It's not suitable for you. You propose that it's 0. You propose that in the top of the theoretic line, there does not exist any pore pressure. But in reality, the pore pressure is negative. But for the points below the theoretic line, the pore pressure calculates from the distance of each point to the theoretic line. For example, if you can see in the next slide, the calculation analysis. Again, we choose a start. Here, grid, define the grid regions. Like former example, 20, 10. After that, draw a slip surface, radius, define the limitation for tangential, number of radius increments, 10, divide into the 10 line, then start calculating. As we can see, very rapid calculation, and finally increase the font size, and you can see here the factor of safety is less. It can be compared with the previous model. In previous model, we use RU, but here, instead of RU pore pressure ratio, we define a phreatic surface, and computer can calculate the factor of safety based on the defined phreatic surface line. You can use just both piezometric line with RU. You can select PW contingent from piezometric line with RU. Together, RU and piezometric line, here, just you can see again for water pressure, add piezometric line, add, select the soil type, define RU, define it, and RU, include RU in PWP. It means the program calculate the pore water pressure from both RU and piezometric line, and we'll add them, and finally calculate the pore pressure. Okay, each point from the distance to phreatic line, also by means of RU. In the next slide, analyze the model. You will see the reduction in the safety factor, because in this model, both RU and pherometric line is introduced, and the pore pressure for the points are greater than the previous model, so the factor of safety will be lower. Here, start. Solve % here, and after they increase the font, you can see the reduction, a serious reduction in the factor of safety now can be seen here. Next, if you want to use a piezometric line with entry and exit surface, okay, entry and exit, I explained it before. Analyze, in the analyze tool, you choose draw a slip surface, entry and exit. Here, click on the left point and draw the region here, and divide the region by 8. Here, number of increment over range, okay? And draw the range in the bottom of a slope. You can divide each range into the, for example, 10, and after selecting the start, you can save this file with another name. Okay, here you can see from each point to each point for larger the font size. You can see here the final, if you choose the correct range for the interior and exist, and the correct range for the grid and radius type, the final factor of safety will be equal. Okay, will be equal, completely equal. So in the next slide, we can see, just because we have a short and time has passed, we introduced you a rapid on the slope stabilization. You can choose here a build geometry, a rapid explanation, build geometry for a vertical cut. In urban area, we has more vertical cuts for excavating the buildings. We use entry and exit. For exit, we just set a point, not a region, because I am going to have the factor of safety for the circles that pass through the top. Here you can see a factor of safety for a vertical cut, okay? Vertical cut in that soil. The soil parameters was similar the previous example. It's not a stable cut because the factor of safety is very less than the unity, and this cut is not a stable manner. Again, see draw a slip surface, entry and exit. The range exit just a point. For entry, click here, define the range, and divide it into some parts, start to calculate, and finally, the minimum factor of safety and the critical surface for that. So we want to stabilize this soil. It's not stable. We have two choices: reinforcement with soil nails and reinforcement with soil anchors. Nails are the steel bars can be placed into the soils and to increase the factor of safety. It's very common in the urban area for stabilize the vertical cuts. Okay, nail. You must define the nail in the soil. The construction procedure is to cut each stage and install the nails. Okay. After that, the next stage and install the next row of nails until the bottom of the slope surface. Here you can see reinforcement load. Okay, the type is nail. After that, you should. I should explain here. You should choose a point of a start of the nail. Okay, the start of the nail into the. Sorry, let me. Draw. Okay, reinforcement load. This window appears. Select the nail type, then a start point to the end point. Here, you just need to approximately draw the nail. After that, here you can introduce the exact length and exact depth of the nail. You can see here, exact is 8 meters with the direction of 20. I'm sorry. With the direction of 20 angle. Okay. Nail. Here. So the nail is drawn. The nail is drawn. Here you can introduce some factors of nail. Just I introduced the title of that. You should work on them, and you should see textbook to determine what is for a soil, for a specific soil and nail, what is the exact amount of these parameters. One of them is pull-out resistance. Pull-out means the pull-out resistance means the strength, the bond between the nail and the soil, F force per area. Okay. After that, resistance reduction factor is the factor of safety for resistance reduction factor. After that, you can see the bond diameter. Bond diameter is the diameter of drilling for installing the nail. After that, you can see the nail spacing, the space between the nails, perpendicular to the plan, perpendicular to the slope. Okay. For example, you install the nails each 2 meters. Nail spacing will be 2. Tensile capacity is the capacity of steel bars, and reduction factor means it's a factor that can be applied. It's a safety factor for tensile capacities, and shear force and shear reduction factor. If the shear strength of the nail you want to include in the calculation, you can use it. But for the bar nails, the bar has a little, a small area, so the shear force is negligible, and you can choose it and 0. So here we have to use the pull-out resistance, bond diameter, nail spacing, and the tensile capacity of the nails. And each row of nails here can see, for example, we use here 100 kilopascal with the resistance factor of 1.5, nail spacing equal to 2 meters, tensile capacity 350 kilonewton, reduction factor 1, and draw another row of the nail like previous, length, direction. Okay, there another row, length, direction. We have it's a large cut, so we define 4 rows of nails here. Okay, after that the program will calculate for us. Please see here, nails, draw a slip surface, entry and exit. We choose the entry, the range for the sliding surface, like previous, like former, here and here for the entry. The number of increment over range 10 divided by 10 points. Okay, start to calculate. Starting solved. You can see here a stable cut. The safety factor is more than unity, so the cut is stable, and the program can calculate the effect of the nails on the stability of the surface and calculate for you the safety factor. Just the final part of our presentation is the reinforcement with anchors. There is a between anchors and nails. Nails just installed into the soil, but anchors first installed, injected in the final, in the end part of the anchor by cement mortar. After the curing, after the getting the mortar getting its strength, we can post tension the anchors. We can have a pre-tensioned anchor and fix the anchor head onto with a edge, with a typical edge. This is a reinforcement, pre-stress reinforcement to stabilize the soils. It's used for a deep excavations, more deep excavations. It's a very good method to stabilize the soils and to control the deformations also. You can here see the reinforcement by the means of reinforcement load, by the means of anchor. Here see anchors. There is some like completely like nails, but there is a different, you can see here. First, we should draw the geometry of the anchors with a length of 8 and the angle of 20. Pull-out resistance reduction, resistance reduction factor, bond length. It's here different. When you choose the bond length, here you can see a red line. It's a bond. It's an area. It's range of the anchor that's covered by the mortar, cement mortar, is and fixed into the soil. It's called the bond length. Bond length is calculated from the end of the anchor. When you choose 3, the program select the 3 meters considered as the bond into the anchors, and 5 meter, the total length is 8. The 5 meter will remain without any bond, without any contact to the soil, and anchor spacing completely large. Tensile capacity of anchors usually are more or greater than the bars, because the anchors consist of the steel cables. The steel cables, you can pull it with the high pre-stress. Tensile capacity, shear force, reduction factor 2, drawing the next row, again, length 8, direction 20 angle, completely like the former row, okay? Again, length and direction, done, defined. All things is defined. So here in the next slide, and I think this is the near final slide, results for anchor. Here draw in the slip surface, entry and exit. Again, define type, select points, just point for exit, type range for entry, and dividing the range into 10 points. The slice will be drawn from each point into the exit point, then start, and program will calculate. You can see here a larger amount of safety factor because of the anchors is more influence, has a more influence on the safety factor of the soil. Thank you. If you want to receive geostudio software full license, send a text message to the mentioned Telegram address with the ID of @Akhtarpour or email of akhtarpour@um.ac.ir or a cell number of you can see here. Thank you very much. If you have questions, I'm ready.
Thank you very much, Dr. Ali. It's been very pleasure to see you today, and thank you very much for sparing this time for us. اخوان الطلبه، اكو واحد عنده سؤال يرفع يده اخوان.
Thank you, Dr. Ali.
You are welcome.
Yeah, I know why the most of students don't have questions, because this is very new to them. So it's been you are very kind to sharing that you will sharing the software with us. Hopefully they will test the software and maybe they will have more questions later. Okay. We can contact you directly, Dr. Ali. Thank you very much for having us today.
Thank you. We can have another session, for example, in the next month after the students work with the software and you are friendly with the environment software, and we can have more explanation for the students, inshallah, in the future.
Yes, definitely. Even we have some postgraduate students maybe will contact you to expand our research with you. Maybe we'll have some cooperation between us for very new research.
A good idea, very good idea.
Yes.
You are welcome.
Thank you very much, Dr. Ali. Dr. Mustafa, do you want to add something?
Thank you, Dr. Ahmed, and thank you, Dr. Ali Akhtarpour, for your fantastic presentation. And I would like to say, if the students have any question in the future, because as Dr. Ali mentioned before, they are not familiar now with this program because they don't had it before. So if they want to install it, because it has some tips and tricks in the installing of this program, and I can help them, and that's all. And I can share my contact details with the student, and they can contact me anytime they would like.
Thank you very much, Dr. Mustafa.
Thank you, Dr. Mustafa. Thank you.
You are welcome. You are welcome, my teacher.
Dr. Ali, behalf of our university chief and our college dean and our department head, Dr. Salmat Abbas, we give you very warm thank you, and it's been very pleasure to see you today. And we hopefully these sessions will be continue with us, and it's been very helpful and beneficial session to all of us today, even our teachers.
Thank you, Doctor. Send me salam to all your colleges.
Perfect. Yeah, we will do. Thank you very much. We have some questions. Last, Zainab, do you have any question? عندك سؤال زينب؟ زينب سمير.